want to take you through an example of question 5 on the ODP numeracy paper. It's in 3 parts, and what I want you to realise is that the answer for each part is used as the input for the next part. So our setup is this. The anaesthetist wants an infusion of a drug preparing. This will comprise a drug concentrate diluted with saline to make the final volume required. So part A tells us that we have a 1.2% infusion, and we're asked how many milligrams of the drug in total will be in a required volume of an 80 milliliter infusion. Now recall that to go from percent solution to milligrams per milliliter, we simply multiply by 10. So our starting point is simply to take 1.2 and multiply it by 10. Now I've said this a couple of times already, but to multiply by 10 we simply move that decimal point one place to the right, so that 1.2 times 10 will equal 12, and our units are milligrams per milliliter. So if there are 12 milligrams in 1 milliliter, there must be 12 times 80 milligrams in 80 milliliter. So we next need to multiply 12 times 80. Now there's a nice trick you can do when you're multiplying two numbers and one of them ends in a 0. You simply ignore the 0, work out the multiplication and put the 0 back in at the end. Now I know that 12 times 8 is 96. So 12 times 80 must be 960, and our units are milligrams. Therefore our answer to part A is 960 milligrams, and we're now going to use this as our input for part B. Let's do that now. Part B tells us that the 960 milligrams that we got from part A must now be drawn up from concentrate. Let me write down my 960 milligrams so I remember it. The drug is presented as 8 milligrams per milliliter. That means 8 milligrams in 1 milliliter. How many milliliters of the concentrate must therefore be drawn? Now this part of the question, part B, is a straightforward liquid dose, and you'll recall it's what you want over what you've got times what it's in. Well, what I want is 960 milligrams. My stock strength is 8 milligrams and it is in 1 mil. So I times by 1 mil. Using my formula, what you want over what you've got times what it's in. Now I'm in a fortunate position because the units on the top and bottom of the fraction are the same, and therefore I can now proceed to working it out. Doing this by hand, I notice that the top and bottom are both even, so I can half it. Well, half of 960 is 480, and half of 8 is 4. Well, I can halve again because that will give 240 over 2. And if I halve one more time, I get 120 over 1. Now the 960 over 8 is simplified right down to 120 over 1. And if I times that by 1, I hope you can see that the answer is just 120. So my answer is 120 milliliters. If you're confused as to which unit goes in the answer, remember this. We gave some thought in this question, as we did in all liquid dose questions, as to the units top and bottom of the fraction, and we made sure they were the same. When they are the same, it's as if we cancel them out. In fact, in a very real sense, we do cancel them out. It's a topic called dimensional analysis, and therefore we are left entirely with the unit milliliter, which is the unit that we use for our answer. So anyway, our answer for part B is 120 milliliters, and we must make a note of that, which we can now use in the third and final part. Now the final part says take your answer for part B and then work out how many milliliters of saline must be added to make up a 130 milliliter solution. Well, this will be a question of saying I have 130 mils that I'll need in total. If I take away the amount I'm going to add, which is 120 millilitres, here we don't even need to do any column working out. The answer is just 10 millilitres. Now, rather than checking as I've gone along on parts A, B and C, I now propose that we go back to the start of this question and review our answers with the calculator. Part 1 involved converting the percent solution into milligrams per milliliter. Let's check our calculator. Clear the decks. 1.2 times 10 should equal 12. Yes, it does. And then because we had 12 milligrams in 1 milliliter, if we now multiply by that value by 80, we should get 960. And that confirms our answer to part A. Reminding ourselves of part B, that 960 had to be drawn up from a concentrate which was presented in the stock as 8 milligrams per mil. So again, using the calculator and just running through that top version, because we can see our units are the same, we have 960 divided by 8 times by 1, and you can see the answer is indeed 120 millilitres. And finally, the last part, we were asked how many millilitres of saline must be added to make a 130 millilitre infusion. It's just 130 take away 120. 130 take away 120. And that confirms our final answer. And that concludes this question example taken from the practice exam. Thanks for watching.